Continuing ahead with our object-oriented programming concepts. In this video, we are going to discuss about encapsulation, inheritance, and polymorphism. Okay. In short, I call them as EIP. Okay, to understand them, we'll again back up to our same old example of class house. Now, when you have a class, with that class, you add values to the attributes, and you create an object. For example, we take back the same house class or home class, which is two sets, right? We have attributes and methods. Okay, so we had room, we had bath, we had bed, door, whatever. Say for example, for this object home3, the properties are, and then turn on heat, turn off heat, right? Let's see, the values are for the room. We have 3 rooms, 2 bath, 5 bed, or this may be what something, and then 2 doors or whatever, and then we have this methods. So inside this object, you're calling this object as home3, and it has these attributes. The values of those attributes are 3, 2, 5, 2, and they have this methods. Methods are actually of class, and it can be used inside this object. And there can be another home, which is for home4, and you can declare that one again with similar properties, which is room equal to 5, bath equal to 3, door equal to 7, or whatever. Okay, so that's how you define a new object. In this case, is called as home4. This is an object. This is an object. House is a class. So let's again take one more example before we get into encapsulation and other concepts. As I already mentioned, the class is a blueprint of object. So once you write a class, you can keep creating new objects. You can have many objects. Object 1, object 2, object 3, object 4. All of this behave like class. So this time we take an example of automobile. Automobile are, which is a class. Okay, what are the objects inside it? So this automobile class will have attributes, right? Attributes and methods. Attributes can be model, year, color, make, and methods can be start, stop, break. So let's create one object. Let's call that object as car1. Okay, and then we'll have another object called as car2. This is object. This is also object. So inside car1, we have the values. Model equal to Civic, year equal to 1997, color equal to black, and so on. In another car, we have model equal to Tesla, year equal to 1950 color equals yellow. Now this car1 and car2 can also be called as, they are the objects, but they can also be used, there can be also another word for them called as instance. So this is an instance. Instance 1, this is an instance 2. It sounds appropriate if we have events, but in this case we can call car1 is an instance of class automobile. Car2 is an instance of class automobile. So this concept is called instantiation. So every time we have a new object, we are basically creating new instance of class. So this is called as instantiation. From there we can move on to our topic called as encapsulation. Okay, let's focus on the word itself where it says capsule. So capsule, I'm just trying to use that word here. What it has inside an enclosure so many things. Okay, so that is the definition of our encapsulation here. It is an enclosure, or it's a box of data and methods within an object. Okay, don't go on the language of this, but it basically means anytime a new object is created, it has a set of attributes and it has a set of methods. Okay, they are enclosed and those values are that of a class. That's why it is called as encapsulation. So encapsulation is one of the concepts in Java programming, basically in object-oriented programming. So when you say car as a class and you say car1 as an object, then this car1 will encapsulate within itself two set of values or two set of content. One is called as method and the other one is called as attribute. Since this car is an instance of class car, it will have the methods of class car, which is turn on, oh sorry, which is start, stop, or brake. It will get it. When we create an object called as car, we do not define anything inside the object called as car. We have defined the method inside the class car, but inside the object we don't define any methods. And then attributes, yes, we set those values inside it, something like gray color, make is Honda, year is 1997. Okay, so these things are embedded inside this object now, these properties. Maybe we have to set the values, but once we set the values, the methods and what are the key value, so keys for the attributes, those come embedded. So that concept is called as encapsulation. So all these things, whenever we create a new instance, like say for example the car2 is a new instance, right? So it comes, the moment you declare car, it has two set of values in it. Okay, one is for method, I mean you don't have method inside is you can call the methods which are declared inside the class, and then you have attribute or properties. Say for example, when you declare car2, you may have color like black and make like Toyota, and then year can be 2000. So this is called as encapsulation. Now let's talk about inheritance. So inheritance is interesting. So say for example, let's talk about a class called as automobile. Now automobile is a wide class, just for understanding sake. And inside automobiles we can have things like car, you can have trucks, you can have convertible cars, okay, you can have like sedans, you can have like cars which is coupes. So different types of cars, and they have their own set of properties. They are under the class automobile because they can move, they can stop, they can start, they can brake, okay, they have color, they have year, they have make, okay, but they have additional properties like this has four door, this has all-wheel drive, this has open roof, this has two doors. So all these properties, additional properties, can help us make a new class which is specific to cars which are of sedan category, or a new class which are specific to trucks, or new cars which are specific to convertible cars or coupe. So this is called as inheritance. It's like something is inherited. So the basic property is inherited from higher class, okay, and then using those and adding new ones, it can be an inherited class, okay. So from an existing class you can make subclass, that is called as inheritance. The last topic is polymorphism. Now polymorphism, the word itself means many forms, okay, but in this case, in the object oriented concept, it means one method act differently. I'm going to write that cleanly. Act differently. So for example, let's say start, okay. Let's take a, before we say start, let's take a class of uh, moving object, or passenger carrier, or we can just say carrier, okay. A carrier, or maybe better, moving object, or a passenger transport, or you can call that means of transport, anything. So you get the idea. We're just going to talk about class called as carrier. So a carrier will definitely have properties like color, make, model, size, mode of movement or transport, mode of transport or motion, so many things. So all these are attributes. Okay, and then we have things like methods. Say for example, start, stop, um, load, unload. Okay, so we had methods like start. Let's see the method as start. So now of these types of carriers, passenger vehicles, we can have, for example, horse carriage. Okay, we can have a car, we can have a two-wheeler like a scooter or a bike, we can have a train, we can have a ship, or you can have a airplane. So all these fall under the category of carrier because they can basically move objects from one place to another place, and they have certain attributes as we already discussed, maybe color, make, model, size, and mode of transport. Okay, now let's validate how the method works on each of them. Say for example, start for horse carriage will be like pulling the rope of the horse. Of the car, it will be just pressing on the gas, turning on the engine. And two-wheeler, it may be similar concept but done differently. In the train, it may be just turning on a different button. In the ship, it may be a different way to start, and plane have a different way to start. So all of these can take in a command called a start, but they act differently on each of them. They operate differently, but same end result. Okay, which is start moving. So this is called as polymorphism. So one method can perform differently on different object, but the end result is same. Okay, which is on same class. So this is called as polymorphism. Now let's encapsulation, inheritance, and polymorphism, let's discuss again. So encapsulation, the E of encapsulation is basically having or gives us information about attributes and methods. Okay, these are encapsulated attributes and methods. They are encapsulated inside the objects because the class is defined like that. And inheritance is something like you have one class, and then you have a class 2 which is inside that class. So class 2 is a subclass of class 1. So this is called as inheritance. And then polymorphism is method with same name actually in the class they are defined as differently, but they have the same name, works differently. So it's basically in the program, how it works differently is you will define it with same name, multiple methods. Okay, all are of same name, but their logics are different inside based on the input parameter. So work differently. Method with same name work differently on different type of objects, type of input, I would say. Okay, so let's again discuss this. Let's make a box to understand how each are related to one another. Encapsulation, inheritance, polymorphism. Encapsulation is for an object because object has encapsulation about attributes and methods. Attributes and method. Okay, so object has both in it attribute and method because they are derived from class. Inheritance is about class. We can get on class C if you add more attributes, add more attributes or methods, you get a new class. And then there is polymorphism, which is basically about the methods. Okay, one more time. Same method, or I should say same name method works differently on different objects.